So I want to talk about equations as a guide to thinking. I'm really trying to give you some tips and hints in a series of videos of how to do well on tests and what tools you have at your disposal. So I want you to understand a couple things. First of all, you have an equation sheet, right? And that's like a cheat sheet. And you can use it in order to help you answer questions. It's there for you because equations are mathematical expressions that show the relationship between variables that are in that equation. So what it allows you to do is you can make predictions, right? You can connect things through that relationship, and then you can see what's going to happen, right? If you increase one or double the other, or decrease something, take half of something. So that's what it's for. So I want to show you a few different examples of what I mean real quick. Let's say you're using Newton's second law, and again, you may not know any of these relationships yet, but it doesn't matter, right now. We're not concerned about what the physics is. You can look on your equation sheet and pick any equation, and you should be able to answer these questions. Like, if I increase A and leave M constant, then what's going to happen to F? Even if you don't know what these things mean, right? Well, if I increase this, then this has to increase proportionately, right? Because this and this are, right? These are directly related. So if I double A, F doubles. If I triple A, F triples, right? Assuming M stays constant. If I look at this example, this is A equals V squared over R. If I leave this R constant and I decrease V, then what has to happen to A? Well, A is going to decrease also. But notice that this is a squared relationship. This is V squared. So when I square it, it has a bigger effect. So if I decrease V, A is going to decrease a lot more. Okay? So if this is half the velocity, right? If I decrease it by half, instead of going 50 miles an hour, I go 25. Well, my acceleration is going to be a quarter as big as it was before. For this equation, this is F equals V over lambda. If I leave V constant, this, and I increase this number here, right? This is an inverse relationship. So if I increase this lambda, then F must decrease. That's called inverse relationship. So this was direct or linear. This here was a direct square or quadratic relationship. This is an inverse relationship. When I increase lambda, F gets bigger. So this equation here is more complicated. There's not just 3 variables, there's 5, right? There's 5 letters on here. But again, it doesn't matter. You're only going to change one thing at a time, maybe 2. So if I leave the numerator constant and I decrease the denominator, notice the denominator is squared. So what happens to this value when I decrease this one? Well, I'm dividing by a smaller number, so FG is going to get bigger. Last example, this is V equals square root of Ft over this Greek letter mu. So if I increase Ft, V is going to get bigger, right? But not quite as big as when it was over here, because this is a square root. A square root cuts things into a smaller piece. So taking the square root of a bigger number will still make this bigger, but it's not going to increase as quickly. So this is how you can use equations to guide your thinking.